Hey guys, it's Thursday and we're looking at our science unit, producing electricity. Over the past couple of days, we've looked at renewable energy sources. We looked at both solar power and wind power, and today we're going to go on to a third one. Today you've got a bit of a choice. I'm going to present two different ones to you. I'm going to present hydroelectric and geothermal power, and you have to just research one of those two and complete. So you get to choose between the two. You need to think which one sounds more interesting to you. Geothermal, which is all about heat energy coming from below the Earth's surface, as you can see in the first picture. And hydroelectric is about moving water, often water released from dams, as you can see here, which then provides the kinetic energy to produce electricity. Okay, so choose one of those two. First of all, I will have a bit of a look at geothermal energy. So geothermal energy, as I said, comes from under the ground. Now, if you decide to do this one, you can pause the video in a little while. Don't do it quite yet, and actually go into these different websites, which will provide more information for you. But I'll provide you a bit more information about geothermal energy now. I need to just jump out of this one for a moment and show you a slideshow. All right. So as we said, it's a renewable source of energy and geothermal. Some of these pictures are going to be quite spectacular, no doubt. All right. And I guess one of the most obvious forms of geothermal energy is in the form of geysers or geysers, however you wish to pronounce it. So what is geothermal energy as an energy source? A geothermal energy source uses heat from below the Earth's surface for heating and generating electricity. Geo is actually part of a Greek word for the earth, and thermal is part of the Greek word for heat. So geothermal put together means heat from the earth. The temperature at the centre of the earth is over 5,000 degrees Celsius. That's pretty hot. It is a renewable energy source. It is a sustainable resource because the Earth's centre is never going to really cool, and it is used all around the world right now for heating and generating electricity. Not so much in Australia, but definitely there are parts of the world which make very good use of it. And it has been used for thousands of years. It was used by the ancient Romans for heating buildings and for water for bathing. This is actually an example of geothermal water that was a hot spring bath built in the 3rd century BCE, before the current era, in China. So it wasn't just the Romans that used it, the Chinese used it as well. How does it work? All right. Pretty much some of this information here could go into the first section of your worksheet. First section. So in general, a geothermal power station uses heat from the earth to produce steam. Holes are drilled down about 2 kilometres to access underground geothermal reservoirs. Now the water here must be really hot at that depth. So this hot water and steam are piped up to the power plant, and it still, even over 2 kilometres, maintains enough temperature to spin those turbines, which creates the electricity or generates the electricity. Currently, it says 24 countries have geothermal power stations to generate electricity. That might be something you can research as to which countries those are. There's an example. This one's actually from a power plant, and I don't even know if I want to pronounce that. Nesjevelia, or somewhere like that. It's actually in Iceland, so it'd probably have a totally different sound in the Icelandic language. But Iceland generates 100% of its electricity from renewable energy sources. Wow, all of it. So geothermal energy produces 25%, and hydroelectric, I got that wrong, didn't I? All of it is from sustainable or green energy sources. 25% from the geothermal, and hydroelectric, the other 75%. That's quite amazing. hence very little pollution. Even though that looks like smoke, it's actually steam, and so that would dissipate into the air and not cause pollution that way. All right, so that's where those slides came from, if you want to know any of those in particular. So don't forget, we are filling in this form here, and that information would go very nicely into that first area, and you can create the energy transformation chain here. Talk about the advantages and disadvantages. A lot of these advantages are going to be similar for all renewable energy, especially when compared to fossil fuels. Okay, are there disadvantages? I wonder. It might be a bit harder to come up with some of those. Alright, so that was some information about geothermal. You can go on to these other websites to find more, to fill in the rest of the information that you need. But I'm also now going to look at hydroelectric, or moving water as an energy source. Okay, so the first thing I might do is show you the slideshow to give you a bit of an idea. So go into this one. Alright, so hydroelectricity. Now, this particular example, you can see that would be coming down a hill and it's through fairly narrow pipes. That would allow water to build up speed, and coming through narrower pipes, it would allow the pressure so that it comes out with such a force that it would spin those turbines. And that's a sort of an example here. So hydroelectricity is the process of generating electricity using falling or flowing water. So you can see the height of the water in the reservoir. Of course, with all the weight of the water pushing down through this intake area, the narrower tunnel must be called a penstock. It's used to spin the turbine. The turbine's attached to the generator, which directly produces power. And then the water's not wasted, it flows out and into a river. So this is a dam built especially for the purpose of hydroelectricity production. And there's an example of one. The attributes at the end will tell us where in the world that actually is. See the size of the trucks here? That gives you an idea of the size of the dam involved. Water is usually stored in a dam with a large wall. Low down on the wall are tunnels that pass through the wall to a turbine. And you can see all that happening in the diagram. Gravity moves the water down through the tunnels, and that turns the turbine. The turbine is connected to the generator, and the generator transforms the movement energy into electrical energy. The electricity is then sent through power lines to people's homes. What energy transformations occur to generate electricity? All right. You've got the movement energy transferred into a different movement energy. So gravity, I suppose, is a form of energy through the generator and into the electricity. The water cycle helps keep the dam supplied with water for free. Therefore, that makes it a renewable energy source. So, here are the advantages. And again, if you decide to do hydroelectric, you can jot some of these down onto your table. It is renewable. Once the dam is built, it's pretty much virtually free. There's no waste or pollution. It's much more reliable than wind, water and wave power, because as long as you've got a water supply, I guess drought's your only problem there, isn't it? Electricity can be generated constantly and as needed. Water can be stored from above the dam ready to cope with peaks in demand. Hydroelectric power stations can increase to full power very quickly, unlike other power stations. Hydroelectric power stations can produce a great deal of power very cheaply, and water can be pumped back up into the dam to be used again. And the water can also contribute to a supply of drinking water. Lots of advantages there. Are there disadvantages? Well, there are some. These dams are expensive to build. However, many dams are also used for flood control or irrigation, so building costs can be shared. Building a large dam will also flood a large area of land upstream. And there have been towns that have been completely reclaimed by dams, but also habitats. So it does cause problems in those ways. You also need to find the most suitable site because it will impact people who live there. And also, I guess you're thinking about where you're building the dam in relation to where the electricity supply is needed. And also, if it's on a naturally flowing river, then the water quality and quantity downstream can be affected. So farms and those sorts of things downstream might have an impact on their ability to continue their crops being grown. There's the slides, which shows exactly where this was around the world. So that was a slideshow about hydroelectricity. There's also, the next part will be the energy chain, and then there's also a video. So let's have a look at the energy chain. Water, or moving water, that's chosen as the energy source. The flowing water directly goes through a turbine. The turbine connects to a generator, and as soon as the generator is spinning, we're getting electricity produced. Have you noticed that a lot of the energy chains for these renewable energy sources are shorter than the ones needed for coal? So you can understand why we're looking into these types of energy productions. It's going to be cheaper and easier all round. So if you need to pause the video to fill in this part, do so now. The next part's going to be a video, okay, and it's going to tell us more about hydroelectric power.
Hydroelectric power is generated using the force of falling water. Water is held behind a dam, forming an artificial lake or reservoir. When electricity is needed, some of the water in the reservoir is released through a water intake in the dam. Gravity causes the water to fall through a pipe inside the dam called a penstock. The falling water spins a turbine, a type of water wheel that converts the water's energy into mechanical power, which is located at the end of the penstock. When the turbine spins, it turns a metal shaft which goes up to an electrical generator. As the shaft turns, it causes the generator to rotate, producing electricity. After flowing through the penstock and across the turbine, the water continues into the river on the other side of the dam. Hydroelectric power is a renewable source of energy. It's also one of the most cost-reliable forms of electric production.
Okay. So this is what you're needing to fill in. You may have already filled in some of the sections now. You've got to decide between geothermal or hydroelectric. There's information about how it's used in general. This is the specifics of the energy transformations. And then you need to talk about the advantages and disadvantages. Now you've had a practice through with solar and with wind power, and you get to choose one today. All right. Enjoy your research. If you need to do more, there's plenty of information there that you can find on the internet as well as in these videos here. Alright guys, that's today's science done and dusted, and I'll see you back tomorrow for more. Okay, bye now.